Hello, everyone. Welcome all of you to attend today's Internet Resource Security Seminar. We know that ISP connect their networks to each other and exchange routing information using the BGP protocol. And as the importance of the Internet has grown, the quality and the security of Internet routing has become critical. Besides, the cryptocurrency is a digital asset that works as a medium of exchange. It uses cryptography to secure transactions and to control the creation of additional units of the currency. BGP security is crucial and essential for cryptocurrency services to maintain the integrity, availability, and the privacy of transactions, and to mitigate the risks associated with routing attacks and the network disruption. We are very glad to invite three senior and experienced speakers today. Doug Madory from Kentik, Aftab Siddiqui from ISOC, and Gendachai from TWNIC. The first speaker, Doug Madory, he is the Director of Internet Analysis of Kentik. Doug Madory is an Internet routing infrastructure expert who specializes in analyzing BGP routing data to diagnose Internet routing disruptions. The Washington Post dubbed him the man who can see the Internet for his reputation in identifying significant developments in the global layout of the Internet. Doug is regularly quoted by major news outlets about developments ranging from national blackout to BGP hijacking to the creation of submarine cables. Doug's speech topic is BGP hijacking, target cryptocurrency service, and the lesson learned. We welcome Doug Madory for the speech.
Good afternoon. My name is Doug Madory. I'm the Director of Internet Analysis at Kentik, and today I'm going to give a talk about BGP hijacks targeting cryptocurrency services and a little about routing security in general. So I wrote up an analysis of the BGP hijacks involved in the Stellar Bridge cryptocurrency attack last year, and I'm going to talk a little about that. We'll talk a little about some of the prior cryptocurrency hijacks that took place in a somewhat similar manner, and have a little discussion about what can be done to prevent these attacks and what can be learned more broadly about how they reveal weaknesses in our internet infrastructure, and I'll talk about some of those routing security mechanisms. So why don't we start with the Stellar Bridge attack. So this occurred in August 2022. And Stellar Bridge, I hadn't heard of it prior to this attack. I don't know. I don't spend a lot of time with cryptocurrencies, but this is a service that allows users to convert currencies between different cryptocurrency types, among other things. And an attacker, a fairly sophisticated attacker, used a BGP hijack to gain control of a portion of the IP address space originated by AWS. So they went after a pretty big target in hijacking AWS address space. So that address space was hosting some of the Stellar Bridge infrastructure, and that allowed them to impersonate it with some copycat code that inserted these malicious smart contracts. So these would then cause the cryptocurrency service to, when conditions were met, redirect digital assets to another wallet. In this case, they were able to, when people logged in and were loaded this page, linked up with their wallets, their digital assets were stolen. And then from there, they were laundered through a few other exchanges to try to hide the attacks, hide the tracks of the attacker. So there's a lot of parts to this that involve cryptocurrency infrastructure, but what I was interested in is how the BGP hijack was so successful. So to make it successful, the attackers had to do a couple of things. These were fairly sophisticated people who were familiar with the weaknesses of our system. And so it's important that we study what are those weaknesses. The first of which was understanding how transit providers build their filter lists automatically based on IRR data. And so one of the weak points, it turns out, is in a service called AltDB. If it's a free alternative to some of the other routing object services out there, and it doesn't have a lot of security around it or overhead. It's a free service, and so the attackers figured out that they could add an entry into AltDB, and then transit providers around the world would automatically suck that up and add a allow for whatever entry you put in there. In this case, they're adding this small, they're extending the entry for QuickHost, which is a small hosting provider in the UK, and saying that they should be allowed to announce Amazon address space to its transit providers, which would be, I think, pretty surprising to someone at AWS or someone familiar with internet infrastructure. Generally, AWS does not need help from a small hosting provider to announce address space. Regardless, they were able to get these entries into AltDB, and the transit providers were able to pick them up as expected and added them to their whitelist. So they would allow these routes to pass. The other thing that had to take place was that the attacker altered the AS path of their routes to forge an origin of AWS in the AS path. So in this case, the AS path was 1299, which is Aurelion, 209.243, which is QuickHost, and then 146.1.8, which is one of the Amazon ASs used by AWS. Having done so, then when Aurelion, which drops invalids, would see this route, it would be evaluated as valid. This is an RPKI valid route. The origin matches the address space, and therefore it would allow this route to circulate. And in the graphic here, this is one of our BGP visualizations from Kentik. And the light green on the timeline is showing, how far these malicious routes, the malicious route propagated. It basically was globally propagated for multiple periods of time in a 3-hour window. It eventually went away. Over an hour later, then Amazon had finally figured out what had taken place, and they started announcing the same /24. Hoping that they would be able to regain control of the address space, which they did, although the attack was had already taken place at that point. So there was an alteration of the AS path to trick RPKI ROV, as well as a bogus entry added into AltDB. So as we mentioned, Amazon didn't announce the /24 until the last hijack was finished, and there were multiple cryptocurrency thefts that took place during this time window, according to Coinbase, who was another cryptocurrency company with a very smart threat intel team that really dissected this, wrote up a great technical brief about the attack. It's important to note that Coinbase was not the target of this. I think that's important to mention. They just did a good job of writing up what took place. If you want more information, you should take a look at their write-up. But like I said, this wasn't the first time cryptocurrencies were targeted. Cryptocurrencies are a favorite target of hackers, because you can instantaneously gain currency, gain money, and there's no way to back it out once it's done. And you can there's ways you can try to hide your tracks. So this all can be done computationally and in a way that you just can't do if you were trying to steal it from a bank. Having said that, in April 2018, we saw, you may recall, Amazon's authoritative DNS service, formerly known as Route 53, had been hijacked. And what we had, there may be other things that were targeted, but the thing that everybody noticed was the DNS entry for My Ether wallet, which was a cryptocurrency wallet service, had been hijacked. And yeah, so the Route 53 was hijacked. It would return a bogus entry of the wrong IP address when someone looked up that domain. It would give an IP address that was in Eastern Europe, Eastern Ukraine, to be precise. And then at that IP address was an imposter website that looked identical, behaved identical, and as soon as you logged in, you had to click through a certificate error, which was very, very disappointing for a lot of people in the security space. Most users did that. They clicked through the error that was highlighting them that there's possibly a security problem. They logged in anyway, and once they did, they had their wallet emptied and their funds stolen. So this was maybe one of the first ones. There's been, I think, several that haven't made the public sphere, but this was maybe the first one that we saw that got analyzed. There was another attack in February 2022, so last year, where attackers went after the users of ClaySwap, which is a cryptocurrency exchange in South Korea, by performing a BGP hijack of IP address space of a South Korean hosting provider that was hosting a library that would get loaded. So the website that users were going to, the web service that they're going to, was fine. It wasn't the target. But when, as you may know, when you load a website, that website is then fetching things from other sites. So you're never just loading stuff from one place, or quite rarely. In this case, the attackers, again, were fairly sophisticated, determined that there was a weakness in the setup, and were able to hijack this South Korean hosting provider, Kakao, and then load in during the hijack, a bogus version, a modified version of the JavaScript library that would allow them to then take over control of the people's currencies and steal them. And so this was a bit more of a kind of a supply chain attack, where you're intercepting the loading of a library, which means that you need to secure not just your own website, but all the other sites that you're pulling stuff from. So that was another one that was successful, fairly sophisticated. And there's I wrote up some analysis, or actually the best write-up is out of the researchers from Princeton, who went through and painstakingly looked at all the details of how this took place. It also reveals some weaknesses in our overall infrastructure. Yeah, so back to the Cellar Bridge incident, I tried to think about like what could be the things that could have helped here, because there was some evidence there that in theory someone could have figured out that they could have been alerted of these incidents when they happen. And so in my write-up, I looked at DNS monitoring. So in those cases, if you have agents around the world constantly making queries, if one of them doesn't match the expected results, then we know that some DNS has been compromised somewhere, and you'd have to react to that somehow. The other thing is, as I mentioned, seeing this quick host this AS 209.243 as an upstream, as like a transit provider for Amazon, that ought to be flagged as an unauthorized upstream, is usually how we refer to it, and deemed suspicious. Whether that could be automated or not is a question. It seems like there's evidence there that it could have been caught. But I think the more important thing is to address RPKI ROV. So in this case, Amazon had a ROA for that prefix that was hijacked, and it didn't help. So why didn't it work? So I think at this point, it's worth putting all this in context and doing a quick detour very briefly on the state of routing security. So, when I started in this space back in 2009, we hadn't really gotten very far in routing security. And I like to refer to this problem space as a constellation of problems that lie on this spectrum of difficulty. From one end, there's just bonehead errors, people making fat finger mistakes that cause disruptions. Those happen. And then on up to the other end of the spectrum of a determined adversary that's very technically sophisticated, that is going to try to defeat whatever security mechanisms you roll out. That is where the cellar bridge thing sits. It's on at that end of the spectrum. So, it's only recently that we've been able to move the needle, so to speak, of like what it is that we can prevent from using automated mechanisms. So there's been a lot of progress that we should take a moment to congratulate ourselves on achieving. And so one of those is that, for RPKI ROV, we have a lot of backbone providers now that reject RPKI invalid routes. We also have a lot more routes with ROAs. So you need two things for RPKI to do its thing. You need to be able to have a ROA that tells you what's the ground truth, and then a network that's rejecting invalid routes. And so the graph on the right is from NIST, the U.S. federal agency that studies lots of technical things, but they have an office that does routing security. It's a graphic from their website showing the trend lines, which are going in a very good direction of the number of valid routes versus routes without ROAs. And this is actually from last year. This is the lines are getting closer. At some point in the next year, they'll cross, and we'll have more routes that are valid than unknown. And on the left-hand side was analysis that I did with our aggregate net flow data, looking at just, in bits per second, traffic getting sent out on the internet. When we throw all of our customer data together, how much is going to the different types of routes evaluated, and based on their evaluation. And we see nowadays about 62% of routes of traffic going to routes that are valid. They have a valid ROA, or they would be evaluated as RPKI valid. So a clear majority of the traffic is eligible for protection, assuming someone's dropping invalids. That's the other key part. And so to address that part of it, we looked at, when we compare how far routes propagate based on whether they're RPKI not found or unknown routes without a ROA or valid. In those two cases, they shouldn't have any issues with their propagation. And then you compare that to RPKI invalid routes, whether V4 or V6, the propagation of invalid routes is dramatically less. And so this is the system doing its job, limiting the propagation and therefore the potential disruption due to an origination leak or something regarding if a route gets evaluated as invalid. So back to cellar bridge. So as I last mentioned, Amazon had a ROA for this prefix. Why didn't RPKI RV help? Because it didn't, is the bottom line. And so there's a couple of causes for this. One is the fact that Amazon, in this address space, and this is common for some of the other address space that they announced, they have, in my opinion, very liberal ROAs. So they RPKI will allow a wide range of scenarios of routes to be evaluated as valid that come from the announced Amazon address space. So there's 3 different ASs that they're allowed to announce the address space, and the prefix size can be anywhere between a /10 all the way down to a /24. In this case, it was the malicious route was a /24. That was a more specific of a /11. Had the max prefix length been set differently, then it would have been evaluated as invalid and would have been blocked by Aurelion from propagating out on the internet. So it's worth noting that since last summer, there was an RFC published, RFC describing the use of max length in the resource an RPKI, and specifically the recommendation is leaving the max length or max prefix length field blank in a ROA, because it has the same effect as just matching whatever is the route that you're announcing, that would be the max prefix length. So if you announce a /23, you don't need to specify the max length. It's an optional field. If you don't specify it, then anything more specific than a /23 would be evaluated as invalid automatically. If you change that /23 to a 22, then everything more specific than a 22 would be automatically deemed invalid. So it's a recommended use that I think was little known until this RFC was published in the past year. Worth considering. But even all this, so I think that would have helped in this case. But it's important to know that RPKI ROV is not really aimed at eliminating the possibility of the impersonation of ASs, which is what is happening in this case. And to do that, you need to have something like BGP sec, which is not fielded presently. This is a routing security technology we hope to have ready to go in the near future. That is what would be how we would cryptographically try to prove the identity of ASs. Now, one of the main critiques against BGP sec is that its protection only extends via contiguous BGP sec aware ASs. As soon as you cross an AS that isn't BGP sec aware, then all the guarantees provided by BGP sec would be lost at that point. And so that limits how far the protection can extend. That's a true statement. But having said that, I think the case of RPKI ROV provides the lesson of the benefits of even just having major networks of the internet. If no one else besides the major networks field a security mechanism, there's a lot of benefit to be had. And so if major cloud providers and major network service providers alone were fielding BGP sec so that between their links you couldn't squeeze in an AS impersonation in a forged route, then that would really limit the efficacy of these types of attacks, and it would have prevented the Cellar Bridge case, and that Aurelion and Amazon would have already had a direct connection. Another route that was, and those routes would be verified by BGP sec. If another route came through QuickHost, the small hosting provider in the UK, and was not verified, then it would be deprioritized over the prioritized secured routes sent directly from Amazon to Aurelion. So I think a lot of us would argue that partial deployment does offer benefits, that the critique aside. So, looking at the numbers around, especially RPKI ROV, I wish there were a couple of facts that became more common knowledge in networking. And the number one is that the majority of internet traffic, measured in bits per second, is directed to RPKI valid routes. That's based on our Kentik's aggregate net flow, which is a very large amount of data of traffic records. We have a lot of traffic right now that is eligible for protection from RPKI ROV. And at number two, route propagation is cut in half when evaluated as RPKI invalid. So there's a lot of efforts out there to measure precisely which ASs are dropping invalids, and it is likely the case that it is a small numeric number of ASs that actually drop invalids. Having said that, we have some very important networks that are arguably more important than others. So not every AS has the same impact on the rest of the internet. And when we have most of the internet's backbone providers dropping invalids, then they end up offering a lot of protection to the rest of the internet, which is a really good thing. And it's important to point out that there have been many engineers at many companies that have worked very hard to get us to this point. So this has been a success story, but there's a lot left to be done. And it's important to know what is the vision for the going into the future. You may be hearing from a certain routing security evangelist sometime soon to hear about what's the vision for the future. But we've rolled out a lot of important routing security mechanisms in the recent years, and they are doing a lot of good. I argue that there are less disruptive routing leaks as a result of some of this work. So that's peer lock, RPKI cleanup of IRR. I mentioned RPKI's, we discussed some of the stats around RPKI. Again, this is more focused on reducing accidental typos, origination leaks. But in the future, if we can roll out BGP to eliminate origin impersonation, and an ASPA, which is a mechanism I haven't mentioned yet, but this is something that allows ASs to publicly enumerate what are the transit relationships that they have, and that would enable other networks to be able to pick out using the AS path what's a valley-free violation and reject those routes. That ought to have a very positive impact on adjacency leaks, which really aren't covered in BGPsec or RPKI. So that's the vision, and it took us honestly many years to get to where we are now, but we're in a better place than we were again when I started back in 2009, and it may take a number of years before those other technologies are fielded in a way that improves our routing security. But we have no other choice. Routing is not going away. The internet's not going away. This is what we have. It's a very difficult problem, and we have no choice but to continue trying to make progress on this. So I hope you'll help me on that. Taiwan is doing a terrific job of RPKI ROA creation. It's one of the best in the world. So look forward to your participation in these other technology rollouts. With that, I would happily take any of your questions. Thank you.
Thanks, Doug. Thanks, Doug, for your very insightful speech for the topic for the BGP hijacking, tagging the cryptocurrency services. Is there any questions on the floor or online audience? We greatly benefit from the information share. I have a minor query regarding your slides. During your presentation, you mentioned peer lock, BGPsec, and the ASPA. Could you please elaborate further on the utilization of peer lock? If it be useful, if you could provide an example for better understanding. It's okay? Wait.
Okay, I'll do my best.
Okay, thank you.
So you asked for peer lock, ASPA, and what was the third thing?
BGPsec.
BGPsec. Well, I'll do my best on that. So let's see. So peer lock was just a mechanism that come up by Job Snyder's, was proposed by him a few years ago, and this was just to get some of the top tier, like backbone tier 1 providers, to add filters where they should never be learning a route from another tier 1. They should never learn one from a customer. And there's like a couple of simple rules that you could enumerate, and you could even automate the generation of these rules to the what type of routes you would accept. I think there's a lot of documentation online on this to maybe explain it a little better than I'm doing right now. But the idea is just you would take the big providers and then make sure that they're not passing leaked routes between them. And honestly, I think that's probably one of the biggest things in these big leaks that we've had in the past. This is something that really limits the propagation of those leaks and the limits of disruption. Let's see. So then ASPA is, as I mentioned, a mechanism where an AS would enumerate who its transit providers or transit customers were. and into a RPKI system. So RPKI is kind of the foundation, and something like ROV is a kind of application that runs over the RPKI infrastructure. ASPA would also be another use case of the data that's stored in the RPKI infrastructure. And so with that, if you knew, if you received a route with an AS path, you could check the adjacencies in the AS path against those stated transit links that are in that would be saved by someone participating in ASPA, and find essentially a valley free. So there's a concept in routing of you don't want AS paths should exhibit some kind of a hill, like you're climbing up transit links down and then to the top and then down the other side. That's the idea. And then if it's a valley, that means there's likely a routing leak going on there, where an AS goes down the transit link, like down to a customer, and then back up to a transit provider. That means that customer is paying two sides for this, two transit providers to move the traffic. Anyway, so that would enable people to find problematic AS path issues where everything else has been kind of origin based, and it's limited to that. And then lastly, you asked about BGP-SEC, and so I'm not the best source information on BGP-SEC as far as some of the technical implementation things. I know there's concerns around, can a router, this is a computational load that every message that was received would have to be checked. There'd be a cryptographic signature that would be checked. If there's a lot of messages coming in, you're asking a router to do a lot more than it was doing in the past. So there's some concern over the computational load that this would put on a router. And I think the idea is that if we were to end up with some sort of a partial deployment, a router wouldn't be checking every one of its messages. It would just be tracking a portion of them, and but that alone would offer some benefit. And then the point I made in the talk, where this protection does not extend beyond into any ASs that are not BGP-SEC aware. That is a limitation of the technology, but I think just like RPKI ROV, there's a lot of benefit, even if you just got the big players to have a secure mesh between them. It would add a lot of security to the internet. Let's see, and there's a question in the chat. More comprehensive details on implementation of BGP-SEC ASPA, associated costs, considerations for hardware and software support. I'm not adequately in this forum here, but like I said, there are concerns around hardware costs, specifically around BGP-SEC. I think ASPA, I don't know, there's less of a cryptographic thing. There's more of a you're just checking AS path against known things, a little bit like ROV is working right now. You have a data set that you're checking the origins against. That's less computationally taxing than doing a cryptographic check.
Okay, thanks, Doug. Is there any further questions? Doug, may I have a last question? Do you have any idea or have any concept to us to encourage ISP to enable their ROV filter? Do you have any idea to encourage them?
To encourage ISPs to do which?
To enable ROV.
Oh, to reject RPKI invalid routes.
Yeah.
Well, I guess the point I was making is part of one of the slides that I had that I worked on with Job Snyder's for last year was to look at, when we look at our all the traffic data that we have, the aggregate net flow, the fact that most traffic is getting sent to routes with ROAs, and then the routes that are invalid, that ought to incentivize someone to create to drop invalids, knowing that people are creating a lot of your traffic's going to ROAs. If you drop an invalid, that means you're protecting how you egress traffic. You're going to not believe a leaked route or some sort of problematic route. So there's the fact that there's a lot of traffic going to routes with ROAs. That ought to be an self-evident motivation to be rejecting invalids. And then the flip side is, given that there's a lot of that we are measuring how the impact on propagation of invalids, that ought to be more a greater incentive to create ROAs, which is of the two probably the easier thing to do. But there's still people who haven't created the ROAs. But I think you benefit at this point because there's so many ROAs out there that your network would benefit by rejecting invalids. Because you're probably going to be protecting a large portion, if not the majority of the traffic that you're egressing by doing so.
Okay, thanks, Doc. Is you any further question on the online or on the floor? No? Doc, many thanks for your attendance. I know the time this is midnight for you, so but many thanks for your attendance, and we give Doc a big applause. Thanks, Doc.
All right.
It's your attendance.
Thanks a lot.
Thank you very much. Wait a moment. There a question. Oh no! Oh, thanks again for Doc's presentation. Thank you very much. So we go to the next. The second speaker is Aftab Siddiqui. Aftab is the technical engagement manager of ISOC. She served as the senior manager, Internet Technology Asia Pacific, and as part of Mana's initiative. Aftab's speech topic is tackling routing security one step at a time. So Aftab is online. So we welcome Aftab for the speech. Let's speak post. Welcome Aftab.
Thank you, Cheng Kang. Thank you for the introduction. And I would say thank you so much for Doug Madory from Kentik. He was being too humble. He is one of the industry leaders in the routing security. So I wouldn't say that he's not the right person. He is the right person to say a lot of things. And I have learned a lot from him. So thank you for all the insight. So let me start sharing my slides. I'm Aftab Siddiqui. These are my details. If you ever reach out to me, if you want to follow me on Twitter, I talk about stuff related to mostly routing security, but sometimes other stuff. So I'll be talking about how you can tackle some of the routing security issues. Doug has already explained what can happen if you don't do the right thing. If you are not protecting yourself from misorigination or the hijacks, then what can happen? So there are certain things you should do. So let me explain what are those things. If you are attending this session, this shouldn't be a surprise to you. There are more than 74,000 networks on the internet and around more than 1 million routes, IPv4 and IPv6 combined together. So there's a lot of addresses. There are a lot of networks on the internet. So before you connect, I give the same example. Whenever you, if you have a house, an apartment, you have to do certain things to make sure that it is secure. You place nice locks in your front gates. At places you put cameras for monitoring, make sure that everything is intact and everything is in perfect order. So you do certain things for your own infrastructure as well when you connect to the internet. And those things are, you create objects in the IRR databases, you create ROAs in RPKI, you update your information in the peering DB, and you make sure that it is up to date. So these are called routing etiquettes. Whenever you connect to the internet, and if you are running a network, you should implement all these things. And that's what we did. I work for Internet Society. We do have a research network. We have the resources from APNIC. So we have two nodes. One is in Sydney, another one is in Zurich. So we have updated everything as any responsible network on the internet. You can have a look at our ASN and find all these details as well. If you look up the route objects, they are created in APNIC IRR database. And we have been announcing our prefixes according to the RIPRIS database as well. Similarly, we have created ROAs, which is the route origin authorization for our prefixes originating from our own AS. So 2/24s, one is coming from Sydney, another one is coming from Zurich. They have both valid ROAs. And the third thing which I mentioned is the peering DB. Again, it's a database where you provide all the details, that where you are peering, which facilities you are in, what is your AS set if you have one, and how can you contact us. So if you go down on that page, there are more details about the contact. So email address is there just in case if something goes wrong, you can reach out. There's a Twitter handle. All this information which can be beneficial for any other network for troubleshooting anything or to contacting us. So the problem is, as Doug was explaining, it's of course there are too many networks. You have to make sure that you provide the right information to everybody else to make sure that they can protect you from anything happening to your network, because it's all interconnected. So you have to provide the right information. You have to make sure the IRR database, the route objects are there, RPKI ROA is there, peering DB information is up to date. So in the normal terms, what we call it is help me to help you. The problem is, which when Doug was explaining the seller hijack, cryptocurrency hijack, he did mention about the all DB entry, which was not accurate. And that is the problem. The IRR ecosystem is based on honor. There are IRR databases which are operated by RIRs, which are the regional internet registries. APNIC is in our region, and there are 4 others for other regions. But there are IRR services which are provided by third parties. For example, RADB, AllDB, and there are many other service providers who provide IRR services as well. So it can have some really it can have bad data in it, misleading information in it. Anyone create route objects for your prefixes or for your region as well in those databases. So what we call it is unauthenticated databases or unauthenticated IRRs. All the IRR services provided by your regional internet registry, which is, for example, APNIC, they are all authenticated. You cannot create route object for any other prefix other than your own. So that helps a lot in terms of security. So what we did is we looked up the RADB data and checked how many misleading objects are there in that database. So the data is available publicly. You can go to this URL at the bottom and have a look at it. We publish this data every 15 days. So you can, if you want to check with the passage of time, if anything has changed in last couple of months or not. So I have only looked at the Taiwan data, so networks from the Taiwan, and the details are something like this. For example, if there is a prefix allocated, so this is the delegated APNIC delegation entry 1.0.4.0/22, which is 1000 IPs, allocated in 2011. But if I look at the RADB, there are 4 different route objects, right? One object is saying that it is originated by AS 56203, another one is saying 24130, and third is 7545, and fourth one is saying 38803. So there are 4 objects. All 4 objects are created by an entity in Australia, which is aapt.com.au, in different times. So one is created in 2021, another one is 2013, and so on and so forth. So they have been creating route objects for different origin ASs for the same prefix. If I look up the route objects with origin of Taiwan ASN allocated to Taiwan networks, then you will find a lot of route objects in RADB. So if I look at them, the predominantly it is the origin is AS4780, and then there are other ASs in the list as well. And who is creating those object is rightly it's at the rate fareast1.com.tw. So it's the same service provider who's creating a lot of objects with their own origin AS, but they are also creating objects for other networks as well. In the list, you can find out the data, as I said, is publicly available. If you want data for your own network, I can provide you that separately. So if you look at it, so more than 10 objects created for the same origin. These are, you will find these ASN in the origin. If the origin AS and the maintainer AS is same, it means that it was created by the same service provider. But in some cases, you will find it's different. For example, here 17408 is the maintainer, where the origin AS is 38851. It could be a subsidiary of the same network or a sister concern, but it is created by other entities. If you look at all the domains, mostly are from Taiwan. So most of the objects are created by network entities in Taiwan for Taiwanese networks. That was for exact delegation or allocation. For example, if I have received a /22 from APNIC, these route objects are for the exact /22, but we know that you can create route object for more specifics. For example, I can create route object for /24, /23 from the same /22. If I look at the more specific from the Taiwan networks, again, you will see 9674, 4780, and 9416 being the most dominant ASN being as the origin AS. One example is this. For example, this maintainer AS4780 has created route objects which are more than 13,000 route objects with origin AS of 9674. But if I look at 9674, they are only advertising 65 routes. So, and if I combine the V6, they are still around 100 prefixes they are announcing. Then what is the reason to have more than 13,000 route objects? Similarly, it's for 9416 and 9919. There are just too many route objects, stale objects exist, which are not being advertised by these origin AS at all. So who is creating these objects? As I mentioned, it's mostly fareast1.com.tw and @hgc.com.hk domain. They have created more than 9,000 objects for 9416. The list is is long. So it's someone from Mike Lee 0987 @gmail.com has created more than 3,000 objects. Hutch City, Taiwan Mobile, Dongfeng. So there are a lot of, for example, aptg.com.tw, they have created objects for many origin ASNs, not for one or two, but many of them, most likely their customers. So if I look at who has created the most, of course, again, no surprises. Anyone who has created 13,000 objects is going to be the winner. So it's problematic in that sense. Let me go before going into the RPKI. So what is the problem I'm trying to highlight here? The problem is, of course, out of those 13,808 objects, only 100 are in the routing table. So anyone can actually misuse the remaining 13,700 objects. And that is the problem. You are creating a loophole in the routing registry where you can actually use any of the stale object and started announcing it. And someone who's not doing actively, not actively dropping routes on the basis of RPKI, of course, it doesn't have a valid route ROA, but it has a valid route object. If someone is only protecting their network on the basis of route objects, then they will accept it because it has a valid route object. So that is the problem. That problem can be easily fixed by if everyone only uses APNIC IRR database, which is authenticated. So that will not be a problem. Talking to Cheng Heng previously, TWNIC doesn't provide IRR services, but you themselves, but they provide you through APNIC. So ultimately, your route objects should be in the authenticated IRR database rather than in the RADB. And if your ASN is listed in one of the list as an origin, you can contact RADB and ask them to delete those objects. Now, the biggest and the better fix is using RPKI. Of course, there are no duct tapes involved in it. First thing you have to do is create the ROA, and the second step you have to do is enable route origin validation and drop the invalid routes. You are not protecting yourself only, you are protecting the whole ecosystem, not only in Taiwan, but also in globally. As Doug mentioned, Taiwan has done a really good job in terms of creating ROAs. There are more than 91% valid route valid ROAs for all the routes originating from Taiwan, which is really remarkable because if you look on the left side, this is the global percentage. Globally, it's around 41% or 42%, depends upon how you are calculating it. But if you compare it with Taiwan, the numbers are really, really good. It's more than 91%. The only problematic part I see is 3.6% of invalids. Remember what Doug says, most of the big operators are now dropping invalids. If a operator is dropping an invalid, it means 3.6% routes from Taiwan are actually not making it to the global routing table in the best possible path. Probably they are reaching it to some part of the world, but not completely because a lot of operators are dropping it. And the path they are taking is suboptimal. So make sure that you look at your ROAs and see if there are any invalid ROAs in the list you have created. To make it simple for you, these are all the invalids. I have looked it up. So if you are a network operator and your prefix is listed here, you can go to your portal and then delete those ROAs because they are invalid, because it doesn't match with what you are advertising. Make sure that you only create ROAs for what you are advertising. Otherwise, they are all invalid. So if you are part of 18412 or 63199 or 1280, please make sure that you delete those invalid ROAs and bring that 3.6% invalid rate to maybe 0, which is the best case scenario. Now, enabling the route origin validation, right? So this is the second step in the RPKI. The first thing is you have to do is create the ROAs. You protect yourself by creating ROAs. And then you protect everybody else by doing route origin validation. It is also, so Taiwan is also doing good in terms of route origin validation. Many operators in the country are actually dropping invalid, but of course not everyone. To make it simple for everybody, I would say everyone should do it unless you are a stub network and you don't have any downstream customers. I think it would be a good idea to start doing route origin validation. In last 1 year, what we have seen, there are some misoriginations happening from networks in Taiwan. We monitor this through Manners Observatory. If you want to have a look, go to observatory.manners.org, and you will find all the details globally and for Taiwan as well. So if you want to know if your network was part of any of the misorigination on leak, you can reach out to me and I can provide you the details about your network. You can also apply for a observatory account by joining as an aspirant account, or you can join Manners Initiative as well if you are doing the right things. The last one is the peering DB. As mentioned, that peering DB is a database which provides you all the details about your network to the global, to the world. For example, how to contact you, where you are peering, which facilities you are located. It also gives you an important data point, which is called AS set. If you are active in the APNIC policy arena, where Cheng Hang is one of the chair, we have concluded an AS policy, AS set policy, where we are now restricting anyone from creating an AS set which is not a hierarchical AS set. What is a hierarchical AS set? Just give me a quick example. Anything marked in green is a hierarchical AS set, where your AS comes first before the name of the AS set. So this is authenticated AS set. No one can create this AS set on your behalf. But anything else, I can create with your name. I can, for example, there is an AS set called AS-TPIX. I can create an AS set called AS-TPIX1. That's it. So I can create anything with the names. If it only involves names, I can create anything. That means I can create the same AS set in different IRR databases. If it is created in APNIC database, I can create one in RADB. I can create, if it is only created in RADB, I can create one in APNIC because they are not authenticated. APNIC cannot restrict me from not doing that. So it creates a problem. So these, if you are part of any of these networks, please make sure that you do not remove or update your AS set into hierarchical AS set. This is not the best practice, and now it is not possible to create one in APNIC database anyway. So please update them. It's a very big problem. I wrote about it in the Manners blog, that how some entities misuse the AS set names and create problems for Amazon and Google not so long ago. So the list is long. Please make sure that you review this list, and if your network is part of it, please fix that. Anyone marked in green, you are doing a great job. You have already created the authenticated AS set. So the solution, do not rely on the third-party IRR databases, RADB, AllDB, or any other third-party or network database which is provided by a service provider. Rely on the IRR services provided by your National Internet Registry, which is TWNIC via APNIC. If also monitor route objects created in other private IRR databases. Use IRR Explorer. It gives you a detail of where your prefix exists in which database. So you can go and delete them and request to delete them from that database owner. RoApTOIC is very good in Taiwan, so all kudos to you, but please make sure that you remove the invalids as well, just to make sure that your routing is optimal. And since the ROA uptake is so good, there's absolutely no reason to use IRR databases, for example, RADB or AllDB. So absolutely no reason. Encourage operators to implement ROV as well. Those who haven't implemented it, I saw someone asking question that what should be done. It is very simple. I do not operate an operational network anymore, but we do have a research network. What we did in that is make sure that we implemented on a edge device first and see if we are dropping something which we shouldn't be. And of course, because we don't have downstream customers, it wasn't a big problem. But if you have a downstream customer, maybe take that feed down to a separate router, your global routing feed, and implement origin validation and drop invalid on that and see the impact. First step, you can just pref or reduce, change the local preference according to the status of the RPKI ROA. If it is valid, then change it to something. If it is invalid, then change it to something else. So you can mark all the invalids you are receiving in your routing feed before you drop them. So this is important. These are all the safeguarding measures. Another one which Doug mentioned is the ASPA. And as someone was asking, what is the cost involved in terms of hardware and software? It is exactly the same as implementing RPKI. It uses the same RPKI framework. It just adds another object, ASPA object. I did a write-up on that on the Manners blog. You can go and read that. It details how ASPA objects works and how it can protect you from the path manipulation. But of course, you have to publish the right objects. So this is all from my end. If you are interested in getting all the details about your network, please reach out to me, and I'm more than happy to provide all the details. You can also log into the Manners Observatory, request for a free account, and I'm more than happy to look into that one. That's all from my end. If you have any question, I'm more than happy to respond.
Thanks, Aftab. Is there any question on the floor or online? You can put your question on the chat, and we can, in Chinese or in English, we will explain your question to Aftab. Aftab, thanks for your speech. We learned a lot about how to tackle routing security. I have a small question about your slide. You spoke about if someone has created those objects for your resource, then contact IRR operators. Could you give more detailed information, or you give some example how to contact IRR operator? Is there any example?
Yes, for example, if someone has created a route object in RADB for your prefixes, or for your ASN. Just giving you an example, if your ASN is 139.038, which is mine, and if I look up that ASN in RADB and see that there are route objects created with my origin ASN, with IP addresses which does not belong to me, I can simply send an email to their support saying, I do not authorize these route objects, please delete them. Because because they will verify you, they will send an email to the technical contact of my ASN, which is me, and say, do you authorize this to delete? And of course, I will authorize that to delete, and they will delete it. Yes, someone else can create it again. That is a problem. So you have to keep an eye that who is creating route objects on your behalf. It can happen with your ASN. It can happen with your prefix. ASN is, of course, I am not worried because I'm not going to advertise anything other than my own prefix. But that means someone else can hijack my ASN and start announcing prefixes, which, of course, does not belong to me. And who will get the blame? I will get the blame. So you always can. Every IRR operator has a support contact. RADB has one. AllDB has one. You can reach out to them and say, please remove that route object. They will contact you through the admin or taxi account, whichever is listed in your ASN or prefix, and you have to acknowledge that email, and they will delete it within 24 hours.
Okay, thanks, Aftab. There are some questions on the chart, and do you read it?
Yes. So the encouragement, I would say, is very important. Is you are not if you are a service provider and you have downstream customers, then you are protecting all your customers from any hijack attempts coming towards them. Number one, I mean, if someone is sending you a fake IP address, you will protect them. They will not be able to reach out to that IP. So that is a good enough encouragement. The second one would be if you are a service provider and how you want to implement it. As I mentioned, take that feed. Of course, you are connected to multiple upstream providers or the transit providers or the peering sessions. Take those feeds and drop it to in a lab environment somewhere, and implement those implement local preference on the RPKI decision. So we know that you can increase the preference of valid or invalid, decrease it for the invalid, and make sure that initially you do not drop anyone, right? And if you see any of your customer in the invalid list, reach out to them saying, by the way, you have invalid ROAs. Can you please remove them? Otherwise, when we implement the validation, your routes will be dropped. The only concern you should have is your own customers. What is happening on the internet? You end up dropping invalids on coming from the internet. It shouldn't be a bigger concern for you. So just drop the invalid, making sure that you're not dropping invalid of your customers. Once that is fixed, you can then drop the invalid. As I said, we have implemented it in our infrastructure because we don't have thousands of customers. It's only internal customers, so it's not a business problem. But yes, if you have many customers, it can be a business problem. Make sure that you do step by step. Job Snyder wrote a very nice script which can tell you how many invalids are there in your routing table. You can test it with that script as well. Otherwise, the easiest way is start implementing local preference on the basis of RPKI. If you do not see a lot of invalids coming in, then just implement it. It's easy.
Okay, thanks. Thanks, Aftab. Is there any question If there are no further question, maybe you have leave your contact email, and if any audience have question, they can contact and you. And thanks Aftab for your speech. Let's give Aftab a big applause. Thanks Aftab.
My pleasure. Thank you so much.